Well, I am going to try my best to explain to you about a special kind of a triangle called a 45-45-90 right triangle. This kind of a triangle originates from a square. As you know, a square has right angles, and this line, the diagonal here, that actually divides the 90-degree angles into 45-degree angles, 45 degrees. And so that's how we get that 45-45-90 is by looking at one of the triangles. Now there's a definite pattern here that's pretty easy to see. In a square, all sides are congruent. So if we use the 8s that I have as the sides and use the Pythagorean theorem, we're going to come up with the length of this diagonal. So let me do this off to the side. Pythagorean theorem, and the C stands for that diagonal. So that'd be 64 plus 64, or 128 is equal to C squared. Now to get C, we're going to take the square root of both sides, so C would be equal to 8 square root of 2. So this diagonal is the length of one side times the square root of 2. And that is the pattern that you're going to see. All right, now here's a summary of a 45-45-90 right triangle where we've got these two angles marked the same, so they must be 45 degrees. The legs are going to be the same, and then the hypotenuse is going to be leg times square root of 2. In this slide, we've got one of the legs of a 45-45-90 triangle is 6. We know it's a 45-45-90 because these two angles are congruent. They'd have to be. So the other leg would be 6, and the hypotenuse would be 6 times square root of 2. This problem looks different, but it's really the same thing. We have to be comfortable with our square roots. We know that the one leg of this 45-45-90 is square root of 2, so the other one would also have to be the square root of 2. Now to get the hypotenuse, we're going to take the leg, which is square root of 2, and multiply it by a square root of 2. That would be the same as the square root of 2 times 2, which is equal to the square root of 4, and the square root of 4 is 2. So all that being said, the length of my hypotenuse in this problem is just the number 2. Okay, in this one now I'm going to give you the diagonal, and it's 15 square root of 2. Now you need to find the length of the side. So what we're going to do is we're going to divide the 15 square root of 2 by square root of 2. These two square roots of 2 cancel out. It will leave you the side length, which is 15. So each of the sides of this square are 15. This example shows you the most difficult type of problem that we'll have with 45-45-90 triangles. It's when the hypotenuse is given. You know that this hypotenuse a leg has been multiplied by the square root of 2 to get an 8. So to go from the 8 to a side length or a leg, you have to divide 8 by the square root of 2. There's a rule of square roots that says you can never have a square root in the denominator of a fraction. So to get rid of that square root of 2 in the denominator, you're going to multiply by 1. And that 1 is going to take the form of a square root of 2 over square root of 2. So that's equivalent to a 1. So when I multiply, numerator times numerator gives me 8 square root of 2 over square root of 2 times square root of 2. That becomes 8 square root of 2 over square root of 2 times 2, which is equal to 8 square root of 2 over the square root of 4, which becomes 8 square root of 2 over 2, because the square root of 4 is equal to 2. Now the 8 and the 2 can reduce, and it becomes 4 square root of 2. So this side is 4 square root of 2, 4 square root of 2. Now, you can check it by checking to see, is 4 square root of 2, in other words, a leg, times square root of 2 equal to 8. And if you do that multiplication, it will show that it is equal to 8. I'm going to have you try to find the answers to these next 4 problems. And then here's the hardest one.